Good day. Welcome to Teledyne Gas and Flames Detection's presentation on how video can improve real-time and post-fire analysis. We're going to be talking about infrared flame detection today. So we need to talk a little bit about how an infrared flame detector works. Flame detection, this is an optical flame detector. Now understand that doesn't mean we're using the camera to detect the flame. The camera is a separate item, but it is looking at the optics coming out, infrared optics. So flame detection is an active method of monitoring a process area for developing fires. It allows early detection of open flames, response, activation. So if we need to turn on a sprinkler system or do something like that, we can do that with this type of flame detector. It's dependent on the flame detector's cone of vision. You see the green on the screen, and the flame detector doesn't actually put out a green light like that, but we show that to give an idea. You can see what area we're monitoring by that green color, and it is a cone area. It's a direct line of sight. So the flame detector, it's a very fast method of detection, but we need to determine which is the right detector. Even though we're talking about IR3 detectors, there are a couple different types here, so we need to make sure that we get the right one. When we talk about optics, what we're looking at is fires radiate over the entire spectrum of ultraviolet, visible, and infrared energy. If we take a look at the chart here on the left, what we'll see is that the visible range is actually fairly small. What we can see with the human eye is not that large. Above that, we see ultraviolet light, noting that there is a crossover a bit into X-rays on that. So X-rays in the area could overlap with ultraviolet, and then infrared with a little bit of an overlap with radar, for example. We also note, if we look at the pictures of the flames on the right, that we have different types of fires as far as the fuel type. So the methanol and the methane fires burning quite blue and hot versus heptane, heavier hydrocarbon type fuel, where you get much more of that yellow characteristic in the flame. We're going to talk a little bit about basic oxidation combustion stoichiometry. Stoichiometry is just a chemical formula, a balanced formula showing what's happening when we're burning a fuel. So typically, if we take a fuel, we add oxygen to it, we have a fire, we get carbon dioxide, CO2, we get water, H2O, and we get that radiant energy that we already talked about. We will usually get other non-ideal components, smoke, carbon monoxide, CO, and carbon, for example. If we look at some examples of this, if we take propane, if we had 5 oxygens with propane in a fire, we should get 3 carbon dioxides and 4 waters. Note, though, if we take another fuel like hydrogen, even though we will mix this with oxygen, we get a burn, we don't get any CO2. There's no carbon in the hydrogen to begin with, so we only get that water. And there are examples where we have metal fires, for example, like magnesium, where magnesium will burn, but we don't get any of the CO2 and we don't get any of the water. Note that we get the CO2 and the water in red. Not only are we trying to highlight those byproducts from these fires, but we're also trying to show that these are hot. So now we take a look at Kirchhoff's laws. Kirchhoff's 3 laws of spectral formation. What we know is that a hot gas will produce only certain bright and narrow wavelengths called emission lines. Kirchhoff's second law states that a hot gas produces an emission line spectrum. So with that, when we take a look at these hot transparent gases, in other words, they're not opaque to the sense that we can't see through them, we get an emission line spectrum. So an infrared flame detector uses this law to take a look at the emission spectrum given off by hot CO2 or by the hot water. This allows us to take a look at those components that are coming off of the fire that we know are going to be there. Kirchhoff's law tells us that CO2 is always going to emit in a certain wavelength, and we can look at that wavelength. You'll see over there on the right on the flame detector that it says an IR3. What that means is that we're looking at this infrared spike for either CO2 or water. We're also going to look above and below that to make sure it's truly a spike, not simply a background infrared radiation increase from something like a hot motor or something sitting out in the bright hot sunlight. So what do we need from a flame detection system? We want to design a flame detection system. What are we looking at? What do we need in that system? Well, critical information to make the correct decisions, right? I mean, if we've got a fire, that's going to be a critical situation. It can be catastrophic. So early detection and action are going to be critical to make sure that the fire is contained and extinguished as quickly as possible. Some of the things we need is that early detection. We want to be able to see this fire within seconds. We need to be able to confirm the fire. A lot of people have had issues with false alarms or not being sure that a fire is real. So we want to make sure that fire is real. We want to confirm the fire. We need to extinguish the fire. We need to make sure we put it out as fast as possible. Fires grow very, very quickly. So the earlier we can actually take action and put that fire out, the better. We want to evacuate personnel. We want to get people out of the area. If we've got a fire, it's dangerous. We want to get people out of the area. And as always, in any fire situation, we have to do a post-fire analysis. Why did the fire start? How did it start? How did it progress? How did the systems work? All of this is critical information in looking at my flame detection system. So what are some of the potential issues we face in a flame detection system? Well, one, inadequate flame detection can be catastrophic. If we miss a real fire event, this can be absolutely a very, very catastrophic and very serious issue. So we don't want to miss anything. We want to make sure we get all the fires. But on the other hand, we want to make sure it's a real fire. If it's not a real fire, if we run into a situation where we say there's a fire and it's not, this can cause a lot of serious issues as well. Let's give a couple examples on this. So for example, when we're talking about the catastrophic nature of these fires, if we look at an NFPA report, this was between 2011 and 2015, municipal fire departments responding to an estimated average of 37,910 fires at industrial or manufacturing properties. This is not residential buildings. This is industrial or manufacturing properties. And this was happening each year, 37,910 on average each year. Annual loss estimated at 16 civilian deaths, 273 civilian injuries, and 1.2 billion in direct property damages. That's catastrophic. So a lot of companies have had bad experience with false alarms. If you've had a false alarm, if you've had a situation where maybe you've dumped a suppressant, you've had something shut down, what it really shouldn't have been, now you've got a cleanup situation, that's not good. A lot of these automatic responses to false alarms can result in serious issues. So with the cost of this, with the issue of everything here in a false alarm, we need to make sure that we do this properly, because unfortunately what happens is a lot of people will simply deactivate their flame detection system, and that's not the right answer. We simply need a better system here to make sure that we don't get these false alarms. Also, we don't want to second guess the flame detection. I've talked to a lot of people who say, you know, we've had false alarms, we've had issues. And so what they'll do is they'll put maybe 2 or more in an area. The idea being that if one detects a fire and the second detects a fire, maybe that's going to be a double check on a system. But the problem with that is if one can be fooled, a second can be fooled. And then what we've done is we've actually spent more money and still sometimes get the same false alarm situation. I've actually talked to some customers who say that they'll send somebody out to confirm that the fire is real. And that can't be the right solution. We know that fires are catastrophic, they're dangerous, people are being killed. Sending someone towards the fire can't be our best option. So why we're talking about flame detection with videos, because it provides a lot of the critical information that we're talking about needing here. So we do have in the video flame detectors that we're talking about, we have both an analog and a high definition. So we've got the older PAL NTSC type of video, but we also have the network video that we're looking at with a high definition. This allows us to see the area being protected. For example, sometimes a lot of people are saying, you know, how do I know that I'm looking at the area that I want to be looking at with my flame detector? By overlaying the camera in here, being able to take a look at the camera, we can confirm that we're looking at the right area. It allows faster and more accurate decision making because we can take that video, we can send it to a remote, safe site. We do that instantaneously. We now have a visual ability to take a look and see if a fire is real without sending somebody out, without wasting time, without endangering someone. We can also direct first responders. We now know in that area where the fire is occurring. So we can say, hey, the fire's on the west side of the facility. Make your entrance from the east. Looks like you can stage here, etc. So that's critical information for your first responders. But we can also direct evacuating people. Many facilities are large. They can be complex. Being able to tell people over, say, a loudspeaker system where the fire is out, where to assemble, what areas to avoid can be critical. We also capture video on this. So after the fire is over, we can come in, we can take a look at the video, we can confirm how the fire started. Did it really start where we thought it might? How did the systems work? How did our responders come in? Did everything work properly? Is there anything we can change to make sure that this doesn't occur again? Or if it does, that we respond to it even better. So that confirmation, we've got the option to put video in these infrared flame detectors, and that can be viewed at a remote site. So that could be a control room, for example. So if we get a flame detection alarm, now a control operator can take a look at that. It could be a security office, for example, and it could be off-site. We need to remember that many of these locations might be very remote, they're unmanned, there's no one there. And so it could take quite a while to confirm if we had to send somebody out, which we don't want to do anyway. So now we can send that video back, and we can do that very, very quickly. It allows a human operator to confirm the fire. So the human operator now is taking over and making that decision on what we're going to do. This helps eliminate the false alarms, and it builds up the trust in the system because people know that if we get an alarm, we can get that visual confirmation with a human operator, whether it's real or not. Again, we talked about some of these locations being remote. We know that some of these might be hours away from people. And so how do we deal with those with a flame detection system? Well, now we can send video around the world. So we can take that video from that remote site, we can send it again to a human operator somewhere else, and they can take actions immediately. They can see what's going on, they can see what's happening, and they can take the appropriate action. Video solves this problem by giving that human operator the chance to see that even from a remote location. Again, the human operator can decide what to do, what steps need to occur. So for example, rather than starting a suppression system, maybe we just need to close a valve feeding fuel to the fire. That may be a much better solution. And by having the video, we can actually see if that might be a solution, and we can see if we take that step, is it enough? If it is, fantastic. That might be a great idea. If it's not enough, now maybe we need to start the suppression system. Again, we can call external support, we can bring people in. And so this video allows the right actions to be taken once a fire has been confirmed. We can also, again, direct these first responders and evacuees. We can do that remotely and safely from, again, a control room so that we can see what's going on. Again, many of these facilities can be large and complex. And so now we can direct first responders in, we can direct the evacuating personnel out, and this can tie into another security video system. So other flame detectors outside the area or other security video systems can all be tied into the same network so that the operator now has multiple views in an area so they can see what's happening. After fire investigation, recorded video can be critical. I've talked to people before where, did you have a fire? Yes, I did. How did it start? Well, we're not sure. No one was there. We think it started here. It might have been this, etc. Video is going to be able to show you, how did that fire start? You can see where that fire first started. How did the suppression system work? Was it adequate? Was it in the right area? Did it do what it's supposed to do? How did the response team do, right? This video is going to be able to assist in all of these things. So this is critical and valuable information that you can use. So what about difficult to see fires? We're talking about using video here, but we know that some fires, especially hydrogen, can be extremely difficult to see. So invisible fires. In the absence of impurities, a hydrogen air flame is almost invisible to the human eye during daylight. So we can't see the fire. What are we going to do? Well, with these hard to see fires, we have an option to put a near infrared filter on these video systems. And this near infrared camera option allows the ability to see a hydrogen fire in a brightly lit area. Near infrared can give a black screen in low light conditions if no flame is present. So obviously at night, but inside a building where we might normally be able to see with color video, near infrared will not allow us to see that. But if we get that hydrogen fire, it will see it, where a color video may not. So color is standard on the hydrocarbon fire systems because we can usually see that hydrocarbon fire. Near infrared is available as an option if you want it for some reason on the hydrocarbon detectors. But for the non-hydrocarbon, like the hydrogen or alcohol detectors, near infrared's a standard. And if for some reason, again, you don't want that, you want color, we have that as an option as well. Right? So we have lots of different options to make sure you can tailor the system the way that you need it for the types of fires that you expect to have and for the area that you expect to be detecting these flames in. So again, a little bit about the color. Human eye is used to color. It's a more natural look for someone to take a look. Obviously, out at an area, they see this just like they would normally see in a camera. But again, it may have problems showing those hydrogen or alcohol fires. It's good for those heavier hydrocarbons. When we're talking about gasoline, diesel, jet fuel, kerosene, things like that, it's fantastic. It's also great for distinguishing the environment around the fire when we talk about, seeing things, directing first responders. So the near infrared video, it's good for those difficult to see fires. In a well-lit location, you'll still see something. We have an example we can show you here coming up, but it will be able to see those hydrogen fires and the lighter hydrocarbon fires, especially like an alcohol fire that can be difficult to see. Again, as a reminder, in low-lit areas, it's going to appear black. So when the fire's not present, if there's no fire there, you're going to have more of a black screen on that. So indoors and outside at night, that's what you're going to see. Here's an example outside of a hydrogen fire. We can see the near infrared video on the left. It gives much more information as far as that hydrogen fire is concerned, but it's a little bit darker to see. We see the color on the right. Fantastic. We've got the color, but a little bit more trouble seeing that hydrogen fire. And quite honestly, this is just a snippet here. If you actually watch the whole video, much better as far as seeing everything on the near infrared. That's actually a plastic container around that hydrogen fire. So some of that is actually the hydrocarbons in the plastic that's burning on the visible camera. So on the color camera, excuse me. So on the near infrared, we're going to be much better as far as seeing those types of fires. So conclusions and summary. Video allows a human operator to see the fire area from a safe location. We can't stress that enough. We now have someone in a safe location who can see the fire. They can see it instantaneously. And instead of relying on the flame detector, which is quite accurate, fast, and good, we now give a human operator the chance to do things. Is the fire real, right? They can make those critical decisions. What actions need to be taken? Again, a flame detector on its own may not have many options. It simply activates the suppression system where, again, a feed line might be what we're looking at. We simply shut down the fuel to the fire. That might be enough. Is that what we want to do? And where the first responder is going to go, and how do we get those people to evacuate that area safely? So recorded video allows that post-fire analysis. Video available in both the color and the near infrared, and this allows us to see the hydrocarbon and the non-hydrocarbon fires like hydrogen. So thank you. We really appreciate you viewing this presentation on how video can help with infrared flame detection. We'd now like to be able to take your questions. If you've got them, we'll take them in the chat, and we'll see if we can't help answer anything that you might have that you'd like to know further about. Thank you.